Hey guys, Mr. Wood here from Mrs. Wood's office. Just going to give a short lesson, just do a couple more of these electron configurations that we were doing in class yesterday. I'm going to kind of bump everything back. I was thinking of having a test on Wednesday, Thursday, and I'm going to push it until the following Monday, Tuesday. It will not be next week. And the assignment that was due now, the lab will be due on Monday, Tuesday, but the assignment 11/2 will be due Wednesday, Thursday. Will be the plan. So I'm going to kind of bump everything except for the lab. The lab, the flame test, and the spectral analysis. You guys can get me that on Monday, Tuesday. Okay, here's the joke. One thing I always do with my AP chemistry students is we have and they make it up. I don't make it up, but we make a class T-shirt, and it's based off chemistry. And of course, for me, it's jokes. So here was the year, and you can see AP chemistry. See, you can figure out 2 potassium 19. Do you know what that means? Potassium is K, 2K19. So this was a class of 2019. And you can see he laughing gas. So a good a good chemistry joke. Okay, so remember what we were doing. We were taking this thing called the off-bow diagram, and I was saying you don't need to remember the rules. You just need to remember how this works. I just want to do a couple more of these. So rule number 1 is you always fill from the bottom up. You always start on the bottom up. Rule 2 is every box represents an orbital, and every box can take 2, and then it's filled. And the actual rule says that electrons have a positive spin or a negative spin. And so when they're filling orbitals, these electrons, there's always one with a positive spin and one with a negative spin. And then the final rule is when electrons are filling orbitals of equal energy, be it the p's or the d's or the f's, what they do is they go one in at a time before they pair up. So again, we fill from the bottom up. Every box can take 2. And when filling boxes of equal orbitals or equal energy, they go one in at a time. Okay, so I want to just go back. I have a little bit of glare here, so hopefully you guys can see this. So I am on the worksheet that we worked on in class. So I'm on this worksheet that says spectroscopic notation. We did a number of these in class yesterday. I'm doing this on Thursday. So let me go. I want to do a couple of these. Number 5. Okay, so number 5 is sodium. Okay, so hopefully you can see that. Again, it's kind of, the glare is not the best. Okay, so hopefully, we'll see. Hopefully you can see this. So sodium, so what I want to do is I want to go till I come to 11. And so I just start here on the bottom. And so the first 2 electrons are going to go here. So that's going to be 1s2. Okay, and then the next 2 are going to go here, the 2s2. And I just want to go until I get till these add up to 11, these uppercase numbers. Remember, the 1 refers to the energy level, the s is the type of orbital, and the 2 is how many electrons are in the orbital. So the first energy level, s orbital 2, second energy level, s orbital 2. So now I'm up to 4. The next thing, again, we're filling from bottom up are the 2p, okay, and there's 3 boxes, so I can put 6 in there, so 2p, 6. Okay, now I'm up to 2 plus 2 is 4 plus 6 is 10. I need 1 more. And so the next available box is the 3s. So it goes 3s1. Okay, so there is the electron configuration for sodium. Okay, now the other thing that we had to do on this was to determine the VE, the valence electrons. Remember, the valence electrons are the electrons in the outermost level. And the easy way to do that is just to look on your periodic table and look at the Roman numeral atop the column. But another thing you can do is you can look here, what's the outermost level? It's the 3rd level, and it's got 1 electron. So the valence electrons are 1. Okay, so there's number 5. Okay, let me do number 1. Okay, so 20 is calcium. Okay, so let me do 20, or I'll do number 1 and number 4, and I'll be done. Okay, so it's not going to be very long. Okay, so again, I'm just filling from the bottom up. Every box can take 2, and I just go till I come to 20. So the first box is 1s2. Okay, so then I go back here, the next box is 2s2. Okay, the next available boxes are 3 of them, so it'd be 2p6. So now 2 plus 2 is 4, plus 6 more is 10. So I need to keep going because I got to get to 20. Okay, so the next available box is the 3s. 3s2, so now I'm at 12. Okay, the next available box are the 3p's. So there's 3 boxes. So now I'm up to 16. So 2 plus 2, 4, 6 more, 10, 12, 18. So the next box, and you got to look close, and it's always confusing. You go, wait, you should fill the 3D before the 4s. And logically, that would make sense, but that's the value of this diagram. You fill the 4s first, and the reason for that is because the 4s has less energy. And that's why right now you need this. And then next week, I'm going to show you how we do this using the periodic table. Okay, so for the valence electrons, again, if you locate calcium on the periodic table and you go to the top of the column, you'd see a 2. Well, those are the electrons in the outermost level. Well, the outermost level here is the 4th, and there's 2. Okay, last one is I'm going to do number 4, which is iron. Okay, so iron is element 26. So again, I'm just going to use the off-bow diagram until I come to 26. So the first 2 go here, 1s2. Okay, the next 2 are going to go in the 2s2. And again, I'm just working my way up from the bottom to the top. Doesn't matter left or right, bottom to top. So 1s2, 2s2, 2p6. So it's always going to go in the same order. Okay, so now I'm up to 10, I'm going to 26. So after 2p is a 3s. So 3s2, so now I'm up to 12. Okay, the next one are 3p6. So now I'm up to 2 plus 2, 4, 10, 12, 18. Okay, and again, this is where we come to where we fill the 4s before the 3D. The 4s is a little bit lower if you look close. So 4s2. Now I'm up to 20, and I want to go to 26. So let me just move this so the glare is, can't see the glare. So what the way this ends is that's supposed to be a 3. 3d6. So there's the final entry. It's 3d6. Okay, and then for the valence electrons, iron comes from the middle. It's a transition metal. So the middle and the bottom, they always have 2 valence electrons. The middle and the bottom always have 2. So if you look here, the 4th level is the highest level occupied, and it has 2. So again, so hopefully you guys spent the 10 minutes or so listening to me do these. Monday we will come back, we'll review this, and then I'm going to show you how we do this using the periodic table. So hopefully that makes sense. And hey, have a good weekend, guys, and I will see you on Monday.